Destroy the layer. Okay. Next. So same topology we are going to perform. I am going to take two PC. Two PC I need, and one router. That's it. This is our small topology. And you can use any network. So I'll use 192.168.1.0 and here 172 network. So right click node, I need a two PC. Virtual PC. Now I need a one router. So PC1, PC2. So this is your virtual PC. So any idea how can we assign the IP address on this virtual PC? Just 1 minute. So here, just make some good looking diagram, text. I'm going to use here 192.168.1.0/24. Change the, I have to format my device. This is a 172.16.1.0. This is my R1. It's taking some time. Okay, so assign some IP address on this PC. This is your virtual PC. In the GNS3, you will get same virtual PC. So here we have to assign the IP address. So IP 192.168.1.1. Okay, with a slash 24 space. Okay, that's it. Hit enter. So IP address is assigned. Now for show IP, like this, you will get the IP address information. Okay, note it down the command. Same like in the virtual PC, IP 172.16.1.1 with a slash 24. By using show command, we can check show IP. That's it. Done. Now just tell me I have to configure my router 1. Okay. I have to configure my router 1. So which command we have to fire here? First is enable config T.
Okay.
If you want to change your host name, change it then.
Interface,
By 0 then.
IP address.
I'm using .10. Then we have two interface there.
172 interface.
0 by 1, then IP address 172.16.1.10 with a slash 24. Yeah? No shutdown.
No sit down.
Allowed in this configuration?
No.
Simple. Copy, come to your terminal. This is your R1. Yeah, now it's ready. No. When you are using the GNS3 or like PNet or EVNG, then you will get the console in the tab wise. So it's quite easy to switch from the one console to the another console. No. It's my online port. It's a very heavy device, so it takes time. When you are working with these ports, online ports, so there, like we have some devices, so it feel like we are working with the real devices. Now simply right click. Then your router is configured. Just one click. Now check the interface information. Do so IP interface bit. So we have two IP addresses. Status is up, method is manual, protocol is up. Now let's check the reachability from the PC1 to the router. Do we have reachability PC1 to R1? No. Okay. Guys, do we have reachability from PC1 to the R1?
Yes.
Is it directly connected? As I told you, when you want to ping from the one network to the another network, in this scenario we need a default gateway. Na? I want to ping from the 192.168.1.1 to 192.168.1.10. Both IPR belongs to same network and they are directly connected. So yes, we have reachability. Let's verify. So ping 192.168.1.10. And see, we have reachability. From the PC to the R1 with this interface G0 by 0. Do we have? What is the IP address of the PC2? 172.16.1.1. And I want to communicate with the R1 interface G0 by 1. Reachability will be there. So ping 172.16.1.10. So yes, we have reachability. Now my task is I want to reach from the PC1 to PC2. Do we have reachability? No. Why? This is not a valid reason. First is going to check like my destination is belongs to different network. If you want to communicate from one network to the different network, then we need a default gateway. Without gateway, if you are trying to ping from the ping 172.16.1.1, no gateway found. Okay, because we are trying to ping from one network to the different network. So in this scenario, we have to assign one default gateway. So this is your command like this. You assign the IP address. You space 192.168.1.10. Done. Gateway. Again check the so IP. So IP. Now we have a gateway.
Right.
Same command we have to fire in the PC2. Space 172.16.1.10. Okay, default gateway is there. So IP gateway is there. Now, when you are trying to ping from the PC1 to the PC2, in this scenario, we have reachability. Why? Now, just tell me, do we have reachability from the PC1 to the PC2? Now, gateway is there. So, with the help of the gateway, your packet is reached from the PC1 to the router 1. Why we are using the gateway in the real time? If you want to ping from one network to the other network, like my PC IP address is 192.168.0.141, my physical IP address, physical PC IP address, and I want to reach to the 8.8.8.8. That 8.8.8.8 is belongs to some different network, and I don't know how to reach that. So simply, I'm going to send my packet to my gateway. This I want to reach there. I don't know route. Can you please help me like this? So we are sending our packet to the gateway. Now, with the help of the gateway, we are sending on packet from the PC1 to the router. Do we have a reachability from the router to the PC2? How can you say this? We have a reachability. It's directly connected, yeah, no issue. But like in the switch, we have a MAC table. With the help of the MAC table, we are forwarding our packet. So in the router, what we have? We have a routing table. Okay. With the help of the routing table, we are going to forward our packet. So come to the router 1. The command is so IP route. This is so IP route. Hit enter. So you can see we have information 172.16 network, 172.16.1.0 network, then 192.168.1.0 network. So in the routing table, we have two network information. Okay. So when you are forwarding your packet with the help of the gateway from PC1 to the R1, now in R1 is going to check what's your destination IP address. What's your destination IP address?
172.16.1.1.
So here we are trying to generate one ICMP packet. My source IP address is 192.168.1.1. Destination is 172.16.1.1. Correct? So I want to send this packet from the PC1 to the PC2. So when you are trying to send this ICMP packet from source 192.168.1.1 and the destination is 172.16.1.1. So first is going to check the destination IP addresses belongs to my network or not. If it belongs to same network, then it's going to forward that message. Before the forwarding, is going to check the MAC address and all. If you don't have, then it's going to generate R. But in this scenario, my destination IP addresses belongs to some different network. So first task is going to check, do we have a default gateway or not? So if you don't have a default gateway, then it's going to drop that packet and it's generating some error like default gateway not found. If you have a default gateway, then this packet is going to forward to the default gateway. Now, this packet is reached to the R1. So R1 is going to check the destination IP address 172.16.1.1. And what is the network IP address of this IP?
1.0.
1.0, like 172.16.1.0. So he's going to check in his routing table, do we have any information about this network or not? So yes, we have. Okay, you can see. We have this network information. And this network is connected with which interface? Gigabit 0/1. So your router is going to forward that message with this direction. Okay, with this direction. So it's going to forward here. Okay. Now again, in the ICMP, we have two things, request and the reply. So your request packet is successfully reached from the PC1 to the PC2. Now PC2 is trying to send your reply packet. So in the reply packet, just tell me what's your source IP address and what's your destination IP address. 172.16.1.1. This is your source IP address and the destination 1.1. This is your reply packet. Okay. So again, your PC2 is preparing for the reply packet. Okay, it's preparing reply packet. So in the reply packet, source is 172.16.1.1. The destination is 192.168.1.1. So these two IP addresses belongs to same network or different? Different. So what is going to do? Huh? First is going to check the default gateway. Do we have or not? Okay, this is our PC. Routing table is belongs to router. This is my PC. So in the PC is going to check, do we have a default gateway or not? So in this scenario, do we have? Let's verify. Is a PC2. So IP. So yes, we have a default gateway. Okay. So now your packet is going to forward to the default gateway. Okay. Now in the default gateway is going to check the destination IP address. This is your destination IP address. What is the network IP address of this IP? 192.168.1.0. Then again your router is going to check your routing table. Do we have a route or not? Do we have? Let's verify one more time. So yes, we have 192.168.1.0. It's connected with which interface? G0 by 0. So it's going to forward your packet via this way. And your reply packet is reaching here. Got it? Do this live in your PC.
So what about the other two, /16 and /32?
32 is like is your specific IP address. Specific IP address.
16?
16 like by default is trying to say like okay this is a class B IP address, so might be it will be 16.
Because we have taken 172, so it is considered better.
But like he's saying okay this IP address belongs normally belongs to class C, class B, but it's a 24. 32 is your local. L means local IP address of this interface. IP address. We assign this IP address now 172.168.1.10 to this interface. 32 means how many IP addresses we have? One particular IP address. So it's saying, okay, this IP address belongs to this interface. Okay. Do this lab, take a two router, take a two PC, one router, try to communicate. You can use DNS3, you can use packet tracer, it depends on you.
Can we do now, sir?
Yes, now.
Okay.
Because after this, we have to discuss some next things. Delhi, we have to do some labs and theory. It's not like only theoretical parts. And you have only 10 minutes. Done, guys. In your case, maybe your interface is fast Ethernet 0 by 0, okay, or maybe Ethernet. It can be anything. So you have to check what is your interface name.
Oh, done, sir.
Done. Okay. So just check do we have a default gateway or not. How it's possible? Check the interface IP address is it's a correct or not. क्या wrong है? क्या? Just check the IP address. You assigned the wrong IP address on the PC2. PC2. Yeah, you can see 173 is there. I told you, like, check the IP address. Guys, done? So now my next task is I want to change my device. Like instead of the PC, I want to take my router. Okay. So same scenario, same IP address, same topology. Just I'm going to replace my PC2 with the router 2. That's it. Stop. Remove the cable. Now my router 2 is coming to the picture. Now. And one more thing, your default gateway is just belongs to end devices. End devices in the sense like PC, router, then printers and all. Okay. So in this scenario, I replace my PC2 with the router 2. So first configure your router 2. You have to assign the IP addresses and all. And your router is taking a decision based on which parameter? Huh?
Routing table.
Routing table, okay. So this is my router 2. So let's configure your router 2. Enable config key, host name R2, interface G0 by 0, then IP address 172.16.1.1. The same IP address I'm going to check. Just we have to replace our PC to the router. That's it. Nothing else. Exit. Okay. Copy. And paste here. Now just tell me, do we have a reachability from the PC1 to the router 2? Guys, do we have a reachability from the PC1 to the router 2? Yes. Then
Yes.
how?
Yes.
No. Then why? Reachability will be there. Sure. Guys, do we have a reachability? Just focus here. Just tell me, do we have a reachability from the PC1 to the router 2?
Yes.
Yes.
Okay. Yes. Okay. Just tell me the scenario. Okay. So this is your request packet. Okay. Now again, we have to go step by step. This is my destination IP address. It belongs to different network. Do we have a default gateway? Yes, we have a default gateway. So with the help of the default gateway, your packet is reaching to the router 1. So router 1 is going to check your destination IP address. Do we have a network information about this? Yes? Let's
Yes.
verify. Come to the router 1 and check it. So yes, we have 172.168.1.0. We have a network. So your packet is going to reach from router 1 to the router 2. Now, router 2 is going to send the reply packet. This is your reply packet. Okay. And this is your router. So how can we check, do we have a router or not? Routing table. Correct. According to you, we have reachability. So IP route. Now just tell me, do we have a reachability?
No.
So how you say like we have reachability? We just assign the IP address on the router to, that's it. Okay. And this IP address belongs to this network. So when you are trying to ping, when you are sending the reply packet, so in the reply packet, your destination is 192.168.1.1. So what is the network IP address of it? 192.168.1.0. But we don't have any route. So your packet is going to drop you. You will get the request packet, but your reply packet will be dropped. I'll show you. Debug IP ICMP. Okay. Now I'm trying to ping from the PC1 to the router 1. Router to ping 172.16.1.1. Request timeout. But you can see here we are getting some logs. It means we have like our request packet is reaching to the router 2. But while the sending the reply packet, we don't have any route. And please don't fire this command in the real time. Okay. Yes. Otherwise, go on. So we don't have any reachability. Okay, so like I'm trying to configure my default router. Okay, as I told you, default router is belongs to end device, but still I'm trying to configure here. Default gateway. Okay, default gateway. What is the default gateway? 172.16.1.10. Now we have a default gateway. Now just tell me, do we have a reachability? Guys, now I configure my default gateway. Do we have reachability? Okay. How can I verify do we have or not? We can check the
So
routing
route.
table. And the routing table, we are checking the route. And here I define my default gateway. These are the two different things. Still, we don't have any reachability. As I told you, like this default gateway belongs to end device. This is not my end device. I configured, but this is not my end device. This is a router. In the router, we are taking the decision based on the routing
Routing
table,
table.
not based on the default gateway. Default gateway is reserved for the end devices. Only end device. Route like PC, laptop, printer, and all, mobile, something. So again, if I'm trying to ping from the PC1 to the router 2, so your request packet definitely is came here, but your reply packet is not here. If I convert my router as an end device, then it will work. Means in the router we have a routing feature. When I disable my routing feature, then it will act as an end device. Then that default gateway will work. So do one thing, just disable your routing feature. No IP routing. Now this router is act as a PC. How can we verify? So again, if it's a router, so we are checking the routing table. Now this is not no longer is a router. Then again check the routing table. So route, do we have any entry? No. It means now this router act like a PC.
PC.
Now check the reachability.
Yes.
We have why? Because my router 2 is act like a PC. But in real scenario, we are not going to convert our router as a PC because router is very costly. If you want to use an end device, so just make sure like put there one PC and all, or you are receiving the routing protocol. IP routing. Okay. Now,
Traffic got dropped because of the earth.
yeah. Now again check. Now I am enabling my routing feature, IP routing. Now check. So IP route you. Just wait. Now we have information. It means now this router act like a router. But my task is I need a reachability from the PC1 to the router 2.
You need the routing protocol.
Now in this scenario, our routing protocol is coming to the picture. Routing protocols. Okay, so in this scenario, we need a routing protocol. It means I need a connectivity from my PC to the router, or instead of the PC, suppose you have one more router. So there is no concept for the default gateway. So in this scenario, we have to use our routing protocol. So basically, we have three types of routing protocols. Which one? Any idea? Routing protocols, like three types. Like we have a static, dynamic, and default. Okay. What the meaning of the static and the dynamic? A normal scenario. What is the static and the dynamic?
Static can change, and dynamic we can change.
Like with the static, we are defining manual things and all, manual configuration. Manually, we have to define our route. Dynamic, it means is going. What is the default? Dynamic, it means is going to take is going to get the routing information automatically. Okay. In a static, we have to do some manual tasks. So in this scenario, I'm going to configure my static route. So my task is like, what is my task? My request packet is reaching from the PC1 to the router 2. But we have some issue with the reply packet. We are not able to send our reply packet to whom? What is the network? Network.
1.0, 192.168.
192.168.1.0. We are unable to send our reply packet to that network 192.168.1.0. So statically, manually, I am going to tell my router, if you want to reach this network, please follow this path. Like we are in CCNA class. In the classroom, there is a CCI room. If I tell you like if you want to reach CCI class, so you can prefer this door. You can go via this door. Okay. Like in the static route, we have two things: exit interface and the net stop. These are two things. We have two things: exit interface and next hop. What the meaning of the exit interface? Okay. So suppose this is you, then this one. This is your CCNA classroom. Okay. And this is you. And in this class, we have two doors. This is your CCI classroom. This is your CCNP classroom. CCI and the CCNP. Okay, this is your CCNA. They are connected directly. Okay, and this is your get one. This is your get two. This is you. Now just tell me, if you want to reach to the CCI classroom, which drawer you are going to prefer? Get one. If you want to reach to the CCNP classroom, then get two. So you are not, you are like you are new student here in the networker's home, and you are sitting in the CCNA classroom. You don't know where is your CCI classroom and the CCNP classroom. Okay, you don't know. So I'm going to tell you manually, if you want to go to the CCI classroom, so you have to prefer this door and this is your classroom. If you want to go to the CCNP classroom, so just go down second floor and there is a CCNP classroom. Means I'm manually telling you where is your destination. If you want to reach the destination, which path you have to prefer. Clear? So in the static also, we have to define these things. Like in the static route, we have two things. Exit interface, it means this is your gate number. Then also we have one next hop. First complete our exit interface. This is your router, R2. We have some issue with the reply packet. I want to send my reply packet to whom? This network. Okay. If I want to reach this network, so what is my exit interface for the router 2? G0 by 0, this is my exit interface. We have to check our exit interface, not of the other one. So if I want to reach to 192.168.1.0 network, so this G0 by 0 is my exit interface. So put it here. Text. So what's your task is 20. Now, just tell me what's your task. Where do you want to reach? Which network? What is the network? 192.168.1.0. You can define your network and the specific IP address, but assume we are defining our exit interface, our network information. You want to reach this network, and if this is a network, then we have to define what is our subnet mask. Maybe I'm using /16/24/8, so we have to define our subnet mask. So I want to reach this network with this subnet mask. Clear this one? This is my destination network and this is a subnet mask. So I'm going to tell my router, if you want to reach this network with this subnet mask, prefer this exit interface. Okay, this is your static route. Same thing we have to fire in the router. Router 2. And again, we have to come in configuration mode. If you want to do any kind of configuration, you have to come in a configuration mode. Now I want to define my static route. So IP route. Okay, this is a command IP route. Now, what's your destination network? 192.168.1.0. With which subnet mask? What is the subnet mask? 255.255.255.0. What's your exit interface? Z0 by 0. This is your static route. How can I verify? How can I verify this is route or IP route? So IP route. So now do we have a route for the destination? Yes, this is. And you can see the S. S means static. We configure this route statically, manually. So now, if I'm trying to ping, this is my ping packet request. Okay. Now again, we have to check our destination IP address. It belongs to different one, so it's going to check default route, default gateway. So we have, so with the help of default gateway, it will reach to the R1. In the R1, we have information. This 191.172 destination. With the help of it, it will reach here. Now is going to send the reply packet. So this is your reply packet. Okay. Now for the reply packet, our destination is 192.168.1.0. It means the network is 192.168.1.0. Do we have a route? Yes. So with the help of the route, it will reach to the router 1. Again, is going to check the destination network. Do we have route? So it will reach here. Let's verify. We have. Clear? Any doubt in this? Guys, any doubt?
No, sir.
Okay.
No, sir.
So do one thing. Remove the PC one. Stop. Delete. Take one more router here. Before it, I want to change the name. Let's make it as a gateway. This is my R1.
Same thing will happen. Because if they try to get transfer to R1, because R1 don't have any gateway and any information about the
Yeah.
other.
So we have to configure here steady
We
ground.
have to configure.
But this time we are going to use our next hop.
We have to be
Next hop. We have two scenario:
next.
exit interface and the next hop. Okay. So just wait. It takes some time. After this, I'll give you one good example, like task, homework. After this, I'll give you one homework. So what the meaning of the next hop? Like I got the idea about what is the exit interface. No. I'm talking about the exit interface. You got the idea what is the exit interface? Everyone clear? Now the next hop. This is my real rec. Okay, and I'm sitting here. How can I check my which exit interface is connected with my ISP or the router? How can I check? Manually, but in your real environment, you are not able to go in the server room. Then how can you check?
Like we have the terminal, like something will be there.
This is my rack. This is I have one switch. This LAN cable is connected with one switch. And in the switch, we have one port. That port is connected with my gateway. Which port is connected with my gateway? You are sitting here, you have one PC. Now just verify. Which port is connected with my gateway? We don't know. So in this scenario, what we are going to do? So like here, suppose this is your scenario. This is your one switch. In this switch, you have around 24, 48 port numbers. This is your gateway. Gateway in the sense like your edge devices and all. This is your router is connected with the switch. Switch. And this is your router. And here also I have one router. Like this we have things. Router, switch, and the router. R2. So suppose if I'm using exit interface in this scenario, F0 by 0, here also F0 by 0. Okay. And let's assume like you know what is our exit interface. F0 by 1 and F0 by 2. And also we have some multiple port numbers. Multiple ports we have in the switch. 0 by 1, 2, 3 like this. 3, 4, 5 like this we have multiple ports. Now in this scenario, I want to reach from here to here with the static route. So like I configure IP route 192.168.1.0 with the /24 0. Okay. Now in this scenario, suppose if I use exit interface, my exit interface is F0 by 0. So my packet is going to drop here and it will reach to this switch. And with the switch, we have multiple routers. Where we have to go then? Okay. Maybe your switch will confuse. Okay, I don't know where I have to forward this message. So in this scenario, we are going to tell my router, if you want to reach some particular network, like this is your destination, and here we have 192 network. Okay. Not a good diagram, this one. And this is my one domain, one broadcast domain. Here I am using 172.16.1.0/24. This one is .1. This one is .10. I have one more router here. This is my destination. And you are the network engineer for your domain, for your broadcast domain. That means you know on which interface you assign the IP address. Connected with this F0 by 1. And here I am using 192 network. Okay. Now your task is you have to reach from the R2 to destination. So if you are using this command, exit interface. Okay. So your packet is going to drop here. Your packet is reached to the switch. Now with the switch, we have multiple routers. Where we have to go? We don't know. So in this scenario, what you can do?
If you know, then you can implement in that case also.
It means you know, like this is my destination. I want to reach this one. And you are the network engineer. You configure all the routers. So you know if I want to reach this network, so this network is connected with the router 1. And we have reachability with the router 1. So I'm going to tell my router R2, if you want to reach this network, particular this 192.168.1.0 network, so you have to forward your data to here. 172.16.1.10. Got the point?
It is going to be 1.10 and 1.0.
1.10.
Default is there.
Your next hop, not a default gateway. It's your next hop IP address. It can be anything, 10, 20, 30, 40, 50, doesn't matter. Means if you want to reach this network, I know if I want to reach this network, so we have to forward our packet to the R1. So I'm going to tell my router, if you want to reach this network with this subnet mask, please forward your packet to this IP address. Got the point? Online guys? Any query in this?
Yes.
Yes? Means you have a doubt or not? So again, one more time, like again, what's your destination? 192.168.1.0. So we have to use our static. So this is my destination network. This is my subnet mask. If I'm using my exit interface, F0 by 0. So your packet is going to drop in this interface and it reaches to the switch. With the switch, we have multiple routers. So in the switch, how can we recognize like this packet we have to forward on which direction? It's going to broadcast all this, like here also we have one router with a .2, .3, .4, .5 with the same subnet, with the same network, because we are using switch 172.168.1.0. So where we have to forward this message?
So it means when there is multiple exit, then we have to use next hop.
Yes. When you have multiple exits, when you have multiple hops and all in your router, in this scenario, you have to select one specific router. Like in this scenario, if I have one more router here, this is a router 3, this is a router 4, a router 5. Okay, the IP address is .3, .4, .5. With this router, we have some different network. We have this router, we have some different network. With this router, we have some different network. It means in this scenario, how many routers we have? 1, 2, 3, 4 routers we have. So with which router we have to forward our packets. We don't know because we have multiple hops, we have multiple exits. So in this scenario, we have to define our specific router. If you want to reach this network, forward your packet to this router. What the point? Let's come to the practical. So R1 is my fresh machine. So this is your R1, IP address is 192.168.1.1. 192.168.1.1. Okay. Copy. Now, do we have a reachability from R1 to R2 in this scenario? So IP route. So IP route. Now just tell me, do we have a reachability from the R1 to R2? No, we don't have. So what do we have to do here? We have to configure our static route. Config IP route. What's your destination network? 172.16.1.0. What's the subnet mask for this network? 255.255.255.0. I don't know what is my exit interface, but according to this topology, I know if I want to reach this network, so I have to forward this packet to this gateway, to this router. Okay, and I am connected with this router on this particular port number G0/0. So for the router 1, this is my next hop. Okay. For this router 2, G0/0 is the next hop. Clear? So what is the IP address of this interface?
192.168.1.10.
1.10. So here we have to define 192.168.1.10. Specific IP address. This is your next hop IP address. This is this interface IP address. It's not a broadcast. It's a particular interface IP address. Because I configured it, na? Yeah, this is your router. In this router, you have two interfaces. You can assign any IP address. Okay. No, not specifically. You can assign any IP address, .1, 2, 3, 10, 100, 200, doesn't matter. Just we have to check who's my next hop. This is my router 1. Router 1 is connected with the gateway and with this interface. So this interface is my next hop. Doesn't matter what is the IP address of it. Come to the router 1. This is your next hop. Hit enter. Let's check to your routing table. So IP route. So yes, we have information. This is okay via this IP address. So we don't have any exit interface. We have to send our packet to this IP address. So first check the reachability, then I'll discuss later. The next point. Ping 172.16.1.1. So yes, we have reachability. Got it? Now one more thing. If you want to reach this network, we have to forward our packet via this way. Okay. Do we have a reachability for this network, for this IP address? Do we have a reachability? We have to check. Where we have to check? If I give if I change my IP address here, like this one, 50, this is my, I can give like this also, 10.1.0.1 something. It will accept. It's going to check so IP route. So we have a route, like if you want to reach this network, you have to forward your packet. First, we have to remove this one. So no. So IP route. It's not going to accept. Why? Because it belongs to some different network. That's why. But sometime it will accept, or maybe by mistakenly instead of the 24, I configure the 16 subnet mask and I give the network information. But we don't have any reachability. So when you are configuring your router, config T, this is your exact one. So IP route. So we have information. So if you want to reach this network, so it's going to send your data to this IP address. So your router is going to check, do we have a route for this network or not? So yes, we have. Okay. Why this way? G0 by 0. It's going to check your exact interface, but with the specific IP address. In this scenario, your specific IP, like the destination is, I have to forward my packet here first. Then it will be handled. Okay. Understood? Do this lab. Right now. Right now. We have 20 minutes. Do this lab. Okay? Do this lab. Right now. Otherwise, you will forget. Okay, guys, just do this lab right now. And the command is
What is the 192.168, the 1.0,
24, it's your network information connected network. And 32 is your specific IP address of the particular port number.
directly connected to
Suppose I configure this IP address in my interface D0 by 0. So it's saying, okay, this is IP address. So this is a network information. Is it directly connected for this network, for this interface? This is my router 1. I assign the IP address on this interface. Okay. And the command, what is the command? This is a command. First, for the exit interface, IP route 172.16.1.0 255.255.255.0 exit interface. For the next hop, same command, IP route 192.168.1.0 255.255.255.0 172.16.1.10. Means this for first router 1 and this one is for router 2. Note it down the first command, then I'll give the one task, big one. Okay. The small task you have to complete here in the lab, the class. Then the big topology you have to configure at your home.
So the mix of that last IP address will be of
Connected interface.
next interface.
Connected next interface. Done. Now the big topology, not a big topology, it's a very small one. Run this. Scared. Do you know how to assign the IP address and all? Okay, no doubt in this. That's it. So, so this is your topology. Okay, guys, this is your topology. Like router 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. You have to select network information by yourself, like 10, 20, 30, 40, doesn't matter. I need a reachability from the router 1 to the router 9. That's it. Okay, this is your task. I need a reachability from the router 1 to the router 9 only. That's it. I'm not going to check the reachability from the router 1 to 5. I'm going to check the reachability from the router 1 to router 9. Network, you have to select by yourself. Okay.
Next hop, we need to select two, right? Interface.
For the router 1, your next of this. For router 2, next of this. For router 3, next of this. In the reply time, for router 5, next of this. 4, 4 to 3, 3 to 2, like this. Okay. Online guys, any doubt in this? What's my question? Got it? What's my question? I need a reachability from router 1 to router 9. Network information you have to select by yourself. Okay?
Okay. Okay.
Okay, then see you tomorrow. Okay, guys? But physically,